This is Coding Math, Episode 44, Kinematics Part 2. In the last episode, we created a basic forward kinematic system where multiple arms were attached to each other and could rotate freely. Today we'll try to improve on this and make it a bit easier to work with. Right now we have to create each arm independently, track its rotation, update its position based on its parent, and render it, all manually in our main code. Adding a new arm to the system requires copying and pasting a bunch of code and carefully connecting it correctly to the previous arm. But the algorithm for what we're doing on each step can easily be extracted and put into another object that can keep track of all this for us. So let's create a new file called fksystem.js. It'll have an object called fksystem. This will have an array of arms and a property called lastArm. This will be a handy way to keep track of the last arm added so we can easily set the parent of the next arm. The system will have X and Y properties. These will be the base position for the initial arm. We'll see how that works shortly. So like before, I'll make a create method that will get XY parameters, create the object using object create, initialize it with the parameters, and return it. The init method will just set this X and Y to the values passed in and initialize the array. Now we need a way of adding an arm. We could make the user of this class create arms and have a method that accepts an arm and adds it to the array. But why not have the system itself make the arms? So we'll make a addArm method. When we create an arm, we need to give it an X, Y, length, and rotation. But within this system, the XY position of most arms is going to be constantly changing. So it doesn't really matter what they are when they're created. Likewise with the rotation. The only real important property we'll need to know to create an arm is its length. So that's all addArm will get. The addArm method will create a new arm with 0 for X, Y, and angle and the passed-in length value for length. And it will add that arm to the arms array. Now if this is the first arm that's being added to the system, the lastArm property will be null. And this arm will not have a parent. But for any subsequent arms added, we want to make the previous arm the parent of this new arm. So we say if arm exists, arm parent equals this last arm. Technically, I guess we don't even need this if statement. If last arm is null, then it would just set the new arm's parent to null, which is what it is anyway. But I'll leave it in there. And finally, we make this new arm the last arm, so that it will be the parent of any subsequently added arms. Now we could deal with positioning arms here, but we're going to be doing that in another function called update. So let's just throw in a call to update here. The update function will run through the list of arms and make sure that the first arm is at the XY position of the system, and all subsequent arms are placed at the end of their parents. So we can set up a for loop to loop through all the arms. For each arm, if it has a parent, we should position it at the end X and end Y of that parent. The only arm that will not have a parent is the first arm, and we'll place that at the XY position of the system itself. That's simple enough. Now we can create a render method. This accepts a context and loops through each arm, calling its render method with that context. Now if you're really worried about performance, you could combine the update and render methods so that you're doing both actions in a single loop. But I like having the two logically separated. Now we'll want to be able to rotate these arms from our main code. We could have the user of this object do this by accessing the arms array with the index of the arm they wanted and assigning a rotation. But that's not so user-friendly. Since we really only want to rotate the arms most of the time, let's just give them a method that does just that. So create a rotateArm method. This will take an index and an angle. This will do exactly what I just described, but it's much more elegant to have a single method for this. Okay, we're ready to use this thing. Don't forget to add both arm.js and fksystem.js to your HTML. We'll create a new fksystem, giving it an XY position, and we'll add 3 arms with lengths of 200, 150, and 100. Then we'll rotate each one of these arms some random amount. In update the system and then render it. And here's the result. All 3 arms correctly positioned and rendered. So far, so good. Now let's animate it. Again, we'll create a base angle variable and remove the initial rotations. In Update, set the rotations for each of the arms. Once again, just grabbing some random values in here. And add a bit to the angle. And we have our animation. Now this is basically where we ended up last week, but from our main code file, this is a whole lot simpler. The creation and management and rendering of arms is a piece of cake now. The only thing that's a bit ugly is the rotation code. If we want to make something like a robot arm where we can manipulate each segment, we could leave it like this. But what I was building towards was creating a walk cycle. In that case, we simply want to set some parameters that will describe how each segment rotates, and then just let the system update itself. So for a walk cycle, you're probably going to want 2 segments for each leg, the upper and lower leg. You could add a 3rd segment for the foot, but I'll leave that as an exercise for the reader. The upper leg will have a range from maybe 45 degrees to 135. Relative to that, the lower leg has a range of 0 to maybe a bit past 90. Remember that the angle is relative to the upper leg. It helps to view the upper portion of the leg at 0 degrees. So now we're not just going back and forth from 0 like we were last time, but going back and forth from some arbitrary angle. One way to look at it is that there's a center of rotation and a range. For the upper leg, the center is 90 degrees, and the range is 45 degrees in either direction. For the lower leg, the center is maybe 50 degrees, with a range of 50 degrees in either direction. These are just rough guesses, and we can tweak them later if we need to. So now we have 2 new values that each arm is going to have, center angle and rotation range. We'll add these to the arm object, and give them default values of 0 and mathpi4. Remember that we need to use radians in code. Mathpi divided by 4 radians is the same as 45 degrees. Now since we're not really using the x, y, and rotation in the arm create or init method, let's just get rid of those. Instead, we'll just create an arm with length, center angle, and rotation range. We'll leave x, y, and rotation to default 0. The create method will pass these new params off to init, which will save them on the instance. Up to now, we've been setting the rotation of the arm with math sine or cosine times an angle variable times another amount. We want to do the same thing here, but internally. So we need to pass that angle value in. But calling it angle is confusing, so I'm going to refer to it as the phase of the walk cycle. So I'll add a set phase method that takes a constantly increasing angle we're now calling phase. Inside that, I'll say this angle equals this center angle plus math sine phase times this rotation range. So if center angle is 90 degrees and rotation range is 45 degrees, math sine phase will go back and forth between -1 and 1, resulting in angle going back and forth from 135 to 45. Okay, that should do it for arm. Let's jump into FK system. The add arm method will now need to take the new parameters, center angle and rotation range, and use them in the create method of arm. Easy enough. It's now going to need a phase property and a speed property. Phase will start out as 0, and speed at say 0.05. In update, we'll do what we've been doing, but we'll also add a call to the setPhase method of each arm in that loop, passing in the phase, and after we're done, we'll add speed to phase. The increasing phase will make the arms oscillate back and forth. Now back in our main code file, I'm starting fresh here, right after we create the FK system. I'll add 2 arms using the new parameters. The upper leg will be 200 in length with a center angle of mathpi divided by 2, or 90 degrees, and a range of mathpi divided by 4, 45 degrees. The lower leg will be 180 in length. Center angle will be 0.7 radians, which is just about 50 degrees, and rotation range will be the same. Now, in update, all we have to do is clear the screen, call FK system update, and FK system render. Bam! And what do we have? The sound of one leg walking. or the view of it anyway. Looks half decent. Let's add another. I'll rename this leg 0 and just create a whole new system called leg 1. Now, if I do this, both of these legs will be exactly in sync and we'll only actually see one leg. But I can change the phase on leg 1 to math pi radians, or 180 degrees. This will put it exactly a half a cycle out of sync with leg 0. So while leg 0 is moving forward, leg 1 will be moving backwards and vice versa. And now we have the sound and view of two legs walking. This is starting to look pretty cool, but it's not 100% right yet. Because the upper and lower leg segments are perfectly in sync with each other, it looks more like someone prancing through a field than walking or running. What we'll probably want to do is have that bottom segment trail behind the cycle just a bit, so it's sticking out straight just as the top segment is coming back down. We can do this by adding a phase offset property to the arm object. This will default to 0. Now in the set phase method, when I calculate the angle, I'll add phase offset to phase. I'll add it into the create and init methods too. And I'll go ahead and add phase offset parameter to the add arm method of the FK system. Now when I add the arms to each system, I'll specify 0 for the first arm and minus 1.5 for the second arm. This will put the lower segment a bit behind in the cycle, so it's still in the process of kicking out when the upper segment reaches its full forward movement. I'll do that for both legs. And here's what we have. This is starting to look good. In this final demo, I've created some HTML slider inputs, and I'm using these to set various properties of each arm, specifically center angle and rotation range of the top segments, and the same for the bottom segments plus phase offset for the bottom. By playing with these values, you can experiment with different walk cycles in real time and see what looks best. And you can mess it up pretty easily too. But just reload the page to reset everything. This file will be in the Git repo for this episode too, so feel free to check it out and see what's going on in there. And join me for episode 45, where we will start to look at inverse kinematics.